Hello everyone and welcome to Simplifying Radicals. For all of the examples that we will complete in this video, we will assume that the variables represent positive real numbers, which basically means that we will not use the absolute value symbol in any of our answers. Also, make note that we cannot take the even root of a negative number and get a real number answer. For example, we cannot take the square root of -4 because there's no real number we can multiply times itself that would equal -4. Okay, so let's look at some examples here. The first one that we're going to look at is the square root of 9 over 25, the fraction 9 over 25, all under the square root symbol. So there's understood to be a little 2 out here in this index, which represents the square root. That means that to simplify this, we're trying to find a number that we could multiply times itself that would equal 9, and a number that we can multiply times itself that would equal 25. So you may find it helpful to rewrite this as the square root of 9 over the square root of 25. Now, the square root of 9 is 3 because 3 times 3 is 9, and the square root of 25 is 5 because 5 times 5 is 25. So my answer would be 3/5. What about the square root of 16y to the 6th? Now we throw a variable in there. To take the root of a variable, you simply want to divide that exponent that's on the variable by whatever the index is, the root. In this case, I would first of all take the square root of 16, and 16 is a perfect square because 4 times 4 is 16. And then take the square root of y to the 6th. To do that, you simply divide the exponent by the index there, or by the root. So that will become y to the 3rd, 4y to the 3rd. Now, if you cannot figure out what the perfect square or perfect cube, when we get to that, is of a particular number, then you can do the prime factorization of that number, or a factor tree. 2 times 8 is 16, 2 times 4 is 8, 2 times 2 is 4. So looking at my prime numbers, 2, 2, 2, and 2, since my index is 2, I'm trying to find pairs of numbers that are alike. So I have a pair of 2's here, so that's a 2. Then I have a pair of 2's here times 2, and you see I will get the same answer of 4. So that's another way that you can simplify radicals. Okay, what about negative square root of 36? That's the same thing as saying -1 times the square root of 36. So yeah, we can simplify this. Trying to find a number that we can multiply times itself to get 36. 36 is a perfect square because 6 times 6 is 36. Therefore, the square root of 36 is 6, and -1 times 6 is -6. So basically, you would just keep that negative that was out there in your answer. Now, what about the square root of -36? Yes, 6 times 6 is -36. However, we're trying to find a number that we could multiply times itself to give us -36. We cannot take the even root, square root here, of a negative number and get a real number answer. Therefore, my answer is no solution. So I can't take the square root or the 4th root or the 6th root, the even root of a negative number, and get a real number answer. Okay, let's look at some more examples here. The cube root of -64x to the 6th. Now this time we have an odd root to the 3rd. So yeah, we can take the odd root of a negative number because we can multiply a number times itself 3 times and get a negative answer. So yes, we can take the odd root of a negative number. Now, if I don't know how to simplify or take the cube root of 64, if I didn't know this was a perfect cube, then again, I can use a factor tree to help me out. 64, the first thing that I think of is 8 times 8 is 64. Break down 8 to 2 times 4. Break down this 4 to 2 times 2. Come to the other side over here with this other 8 and do the same thing. Break down the 8 to 2 times 4. Break down the 4 to 2 times 2. So I have, as my prime numbers, 6 2's there. Now this time I'm looking for the cube root, which means I'm looking for 3 of a kind in my prime numbers to put in a group. So I have a 2. Then I have another group of 2's, 3 of a kind. So that tells me that 2 times 2 is 4. The cube root of 64 is 4. If I would have been looking for a fourth root, then I would have been looking for 4 of a kind to put in a group. So I have a negative here. So that tells me that negative 4 times negative 4 times negative 4 is negative 64. And now I want to take the cube root of x to the 6th. Again, all you have to do is to divide the exponent by the root. And that's how you would simplify that. So negative 4x squared. Okay, so what about the cube root of 1/8? Well, we can split that up again to make the cube root of 1 over the cube root of 8. Trying to find a number that I can multiply times itself 3 times to give me 1. Well, 1 times 1 times 1 is 1. So the cube root of 1 is 1. What can I multiply times itself 3 times to get 8? Again, if you don't know, you could do a factor tree and you're trying to find a group of 3 of a kind to put into a group. So here, the cube root of 8 is 2 because 2 times 2 times 2 is 8. So my answer would be 1/2. Okay, the fourth root of 256x to the 8th. Well, we may not know what the fourth root of 256 is, so let's break it down. So first of all, we would start off by dividing by 2, since it's an even number. That makes it a little bit easier. So 256 divided by 2 is 128. 2 and 128. And then we could, sorry about that, break down 128 by dividing it by 2. 2 would go into 128 64 times. 64, 2 would go into that 32 times. 32, 2 times 16, 2 times 8, 2 times 4, 2 times 2. So you see I have all 2's. I'm looking for 4 of a kind to be able to bring a 2 outside of my radical. So I have 1, 2, 3, 4 here, 4 2's. That tells me I have 1 2 outside of the radical. Then I have another group of 4 2's. That tells me that the fourth root of 256 is simply 4. That means if I multiply 4 times 4 times 4 times 4, I would get 256. Now x to the 8th, the fourth root of x to the 8th, just divide those, give us 4x squared. Okay, let's look at one more example. Negative cube root of z to the 21st over 27x to the 3rd. So let's keep the negative on the outside there. Let's separate the radical, z to the 21st over the cube root of 27x to the 3rd. So far as my variable, I would just divide the exponents. 21 divided by 3 divides evenly, so that's z to the 7th. The cube root of 27. I'm looking for 3 of a kind in my prime numbers, and I have 3 3's there, so the cube root of 27 is 3. Exponents, divide the exponent by the root, will be 3 divided by 3 is 1, so x to the first. So my answer, negative z to the 7th over 3x. Okay, I hope you found that video to be helpful. Look forward to seeing you again. Thanks.